Hey friends, welcome back to Civil Engineering Mastery. In this video, we are going to discuss about the free body diagram. It is one of the very basic element in structural analysis. If you wanted to analyze any type of structure, you should know these basic things. Then only you can analyze the structure properly and you can find out all the forces acting on the structure. So when you apply the forces, external forces, there will be a internal forces developed in the structure. So our main objective is to find out the internal forces developed in the structure due to externally applied loads, and then accordingly we need to proceed the structural design. So let's discuss what is free body diagram, how we can draw the free body diagram, what is equilibrium equations, and how the free body diagram helps in finding out the internal forces are developed in the structure. So without further ado, let's begin now. First, let's start off with what is free body diagram. It is a graphical representation used to analyze and understand the forces acting on a structure. This free body diagram helps to break down the structure into individual components, and then we need to identify the forces and moments acting on the individual components of a structure. This helps the engineers to assess the equilibrium of the structures, and they can calculate the internal forces, and then they can ensure that the design meets the necessary safety and stability criteria. So this is the main purpose of the free body diagram. Before getting into the free body diagram of individual structural member, let's discuss what is equilibrium. As per Newton's law, a structure is stable when the externally applied loads and the internal forces developed in the structure are equal. If there is an unbalanced force, then the structure will not be stable. The structure will start to move. So that is why we have to follow the equilibrium condition. We have three equilibrium equations for a 2D structure. Summation of horizontal forces are equal to 0. Summation of vertical forces are equal to 0. And summation of moments are equal to 0. So external load and internal forces are in equilibrium. If the structure is said to be stable when it satisfies the equilibrium condition, if the structure is said to be unstable if it is not satisfying the equilibrium condition. Now let's see how we can draw the free body diagram. Here we have a beam with one end hinged support and one end roller support. So here we should know the support reactions to draw the free body diagram. So if you wanted to know more details about the support reactions, how we can create the support reactions for each support conditions, I have already uploaded one detailed video about it. I'll be providing you the link in the description box. If you want, you can check that one. So for hinged support, we'll be having the vertical reaction and horizontal reactions. Since we have the vertical load which is applied on the beam, so we have only vertical reactions, and for roller support we'll be having only vertical reaction. So to draw the free body diagram, you have to isolate the structure from the support. So first we have to isolate the structure from the support, and then we have to draw the reactions. This is the externally applied load and these are the support reactions. So if we consider this one as A and this one as B, this is your reaction A, RA, this is RB. So this is the free body diagram. We can simply represent it as FBD. Next, if we look into this beam, we have both side hinged support. So we'll be having one vertical reaction over here and again here one vertical reaction. So let's draw the free body diagram. It looks similar to the previous one. So we'll be having the reaction, vertical reactions, and this is the applied force. This is RA and this is RB. In case if the load is acting inclined instead of vertical like this P, your reactions will get changed, because since we have hinged support on both sides, we will be having the horizontal forces too in addition to the vertical forces. Then the free body diagram looks like this. This is the inclined force. If the inclined force is acting, so you will be having the reaction, vertical reaction Ra. In addition to this, you will be having the horizontal reaction that we can call it as Ha. And similarly, here also you will be getting Rb as vertical reaction, and you will be getting the horizontal reaction here Hb. So this is the free body diagram, and we have different loading condition, two different loading conditions. So according to that, the free body diagram will get changed. Next, let's look into the cantilever beam. For fixed support, we have one vertical reaction and one moment. Let's draw the free body diagram for this. So the free body diagram looks like this. When the load is applied at the free end, we'll be having the reaction over here and the moment. So this is your Ra and this is your Ma moment. This is the free body diagram for the cantilever beam. Next, let's look into this beam, which is having both ends as a fixed support, and the load is also acting inclined. So when the load is acting inclined, we'll be having the vertical reaction, horizontal reaction, and then moment. So all three forces we will have on both sides: vertical, horizontal, and moment. So when we draw the free body diagram for this, the load is acting like this. We'll be getting the vertical reaction, which is Ra, and this is Ha, horizontal reaction, and moment Ma. This support also the same. We have Ra, Ha, sorry, this is Rb, and this one is Hb, and then this we can say it as Mb. This is the free body diagram when you have both end fixed and the load is acting inclined. If the load is acting vertical instead of inclined, you will have the free body diagram. You will not be getting this horizontal reaction on both sides, and only you will be having the vertical reaction and the moment on both sides. So this is the difference if the load is acting vertical and if the load is acting inclined. Next, let's look into the free body diagram for the truss. So you have to isolate the truss from the support, and then let's apply the load. So the load P is acting at joint D and joint E. So these are the externally applied load, and let's look into the support reaction. So here we have the support reaction Ra and Rb. This is Ra, this is Rb. Since we do not have the horizontal forces acting, so we do not get the horizontal reactions. Summation of horizontal forces are equal to 0. So here there is no horizontally applied external load, so we will not get the horizontal reactions, support reactions. So this is how you have to draw the free body diagram for the structural members. So friends, I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. If you really like the content, hit the like button and also share it with your friends. Thank you for watching.